Welcome to the next lecture. In continuation, we are going to discuss few numericals with you on the basis of the topics we have taken till now with you in the previous 4 lectures on kinematics. And of course, it means you should be having the previous knowledge of speed, velocity, and acceleration and equations of motion. And then you should be having the knowledge of graphs, how to do the graph plotting, which is very, very important. And then you will be able to work out all the questions coming across you. The first question with you, in which we are asking you to suggest a suitable physical situation for each of the following graphs in the figure which are given to you. Of course, 3 graphs are given. One is the position time graph, another is velocity time graph, and the third one is acceleration time graph. That you can always come to know by looking at the graph. Time here in all the graphs is taken along the x-axis. Like talking about the first graph with you, this is xt graph, means position time graph. Position time graph, you can see that position is not changing. Of course, here at the origin time is 0, means before that when negative time is there. So if anybody is asking you time can be positive, time can be negative, or time can be 0, of course it cannot be, but we can assign them values for our easy study. So it means before I start noting, somebody else was noting. So this is with reference to that the negative time can be taken. So it means initially the body is at rest, position is 0, x is 0. Then the position is getting changed, it is getting the position, some position it is getting. Xt graph, slope of the xt graph gives you velocity. So it means uniform motion is there. Position is equal displacements in equal intervals of time, means uniform motion is there. And then again uniform motion, because slope is there but decreasing. It means position is changing but with a decrease, and then it is coming to rest, but not at the x equals to 0, but x having some negative value. This is this is when I am taking the time axis. This at the origin time is 0, position is also 0. When I go to the left, time is negative, and when I go to the right, time is positive. When I am going on the upper side, it means position is positive, and when I am going below side, then position is negative. I have read the graph for you, what is being depicted in the graph, that body is at rest, then it is moving, uniform motion, but now it is reversing, position is decreasing with time, and then it is coming to rest, but not at 0 position, not at the origin it means, but at the negative position. What is happening, it is moving, changing the position, positive direction, then it is striking a wall, or you can take any ball is here kept, ball is moving in the straight line. Of course, this chapter is all about motion along a straight line, so that you have to always keep it in your mind. So body is moving along the straight line, it strikes the wall, it returns. It means position starts decreasing, and then it crosses that initial point origin, and then it goes beyond that in the negative direction and stops here. So this is the pictorial depiction of the physical situation. You may say that the body is initially at rest, then it moves in the positive direction, then it turns back, it means now position starts decreasing, and then it crosses the mean position and comes to rest. So this is the depiction for the physical situation. And then of course you can write in words, because they are asking to write you people in words, that you can write yourself. Second graph is for velocity time graph. Velocity time graph, you can see here velocity is having some positive value of this above the 0 line, this is a reference line with you, 0 line I may call. Then above I'm taking positive, below I'm taking negative by convention only. So positive value of velocity is there, velocity is decreasing, is becoming negative. Speed cannot be negative, but velocity can be negative. So you have to see if even they write v, but if it is only positive, then they are talking about speed. This is positive and negative both, means they are talking about velocity. So this is velocity time graph. Velocity is positive, 0 and then negative. And then you are coming with the decreased velocity, which is again positive, 0, negative and so on. You are coming with decreased velocities when the time is passing. So it is, you are throwing the ball up. It means you are throwing with some initial velocity. And then at the highest point it becomes 0. And then when it comes down, it decreases. And direction is also changing. Earlier upward direction taken positive, downward direction taken negative. So if you can be asked to draw the graph, plot the graph for a body which is falling from a height, then you will start the graph from here, origin, 0 velocity. But now because the graph is coming with positive velocity, so you have to say a body has been thrown up, which rebounds back, and on every strike with the earth it is losing its velocity, upward velocity, and that is why I am getting the velocity decreases there. I think it is clear with you, beta. So what it is, you should be able to understand the graph is very, very important. I can join this point and this point. This value is same, rather decreased value. Here if the velocity is say 5, here velocity is becoming 4. Then here velocity is becoming 2. Only the direction is changing. When it is striking the ground, the direction of the velocity upward is taken as positive, and when it is falling down, negative. Downward velocity is taken as negative. So you have to keep the sign in your mind. This is acceleration time graph. It means initially acceleration is 0, then it gets some acceleration and then decreases. Acceleration is becoming negative, firstly positive, then negative. If you want to take the ball, you kick it, but on the ground only in one direction. When you are kicking it in the upward or downward direction, then velocity will be changing, and see slope is constant. So acceleration is constant. Constant acceleration means it should be on the time axis only. This is constant acceleration. And this is increased acceleration. The body is not at rest here. See the difference. XT graph, position is at rest. AT graph, this is acceleration is constant. It means body is still in motion. But with constant acceleration, then you accelerate by pedaling. You are changing the acceleration. Then you are retarding. Then you are bringing with constant acceleration. The body is not coming to rest at all. Only like while traveling any vehicle, you put your feet on the accelerator and then you remove. So you accelerated the car and then you come with the constant acceleration. This acceleration is 0 when you are taking, then acceleration can be taken 0, but does not mean that body is at rest. It can move with the constant velocity. When the body is moving with constant velocity, then also acceleration is 0. When body is having velocity constant, then acceleration is 0. That should be known to you. You can have a car which is moving with uniform velocity, then you accelerate and then deaccelerate, and then it starts moving with uniform velocity. It is not coming to rest. So that is why all these three graphs I have taken. They may give you different types of graph, whether possible, not possible. You should be able to understand how to read the graph. That is very, very important. Okay. You below graph, it is a position time graph, xt graph of a particle moving in one dimensional motion. It means we are talking about motion along a straight line. Three different equal intervals of time. It means this t1, it is equals to t2, it is equals to t3. Intervals of time are equal. In which interval is the average speed greatest? Average speed will be equals to the total distance upon total time. Total time is same in all the three intervals. So it means you have to see the angle theta. Slope of xt graph gives you speed or velocity. So this is giving you average speed they are talking about in a given interval. So if the slope is more in the third interval, you can see. So theta is more in third interval. So average speed will be more in the third interval, but if because it is taken negative direction, so it means it has to be velocity, and that is why they are talking about the signs of average velocity for each interval. For first and second interval it is positive, for third interval it is negative because it is negative side. Upward is taken positive, downward is taken negative. So first and second is positive, third is negative. So this was a very simple question with you. Next question, if you see, now they are giving you speed time graph. Similar question, slopes you have to see. In which interval average acceleration is greatest in magnitude? Because slope of speed time graph will give you acceleration, that is known to you. Slope of position time graphs gives you speed or velocities. Slope of speed time graph gives you acceleration. So again you have to see the slopes. In which case the slope is more now? Second interval. In which time interval average speed is greatest? Average speed. Because here you see the value of speed is going to be less. Here for this point the speed is more, and for D point the speed is having the greatest value. So average speed, of course magnitude will be more for D in as compared to A, B, C and D, of course. Which interval they are saying? So third interval. Third interval the average speed is greatest because magnitude you have to see. Okay. They are asking choosing the positive direction as the constant direction of motion. Give the sign of the speed and acceleration in three intervals. Speed, of course, is always positive. So speed is positive in all the three intervals. And acceleration, here it is increasing. First interval positive. Here it is second interval it is decreasing. The magnitude is decreasing. So you will be getting the negative value. And here it is again approximately constant but positive only. So this is second interval where the speed is decreasing. Next question is, what are accelerations at the points A, B, C and D? At A point you see slope is 0. At B point slope is 0. At C point again the slope is 0 because you are getting a line parallel to the time axis. Here also the slope is 0. So all the 4 points A, B, C and D slope is 0. Slope of speed time graph is 0. It means acceleration is 0. Clear? Slope of speed time graph gives you acceleration, and at all these 4 points A, B, C and D is coming parallel to time axis. Like we have discussed, the slope is given by the when you take the derivative at a point, means slope at a point. So at the maxima, at the minima, slope is 0 means derivative is 0, or I can say the acceleration is 0. So this you have to keep it in your mind, how to see the slope, that is theta angle. Next question, very easy question with you. A boy is standing on a stationary lift which is open from above, who is throwing a ball upwards with a maximum initial speed he can, equal to 49 meter per second. This is the initial speed. How much time does the ball take to return to his hand? So it means it is moving in the upward direction. At the highest point velocity will be 0. So initial velocity is 49 meter per second, but the final velocity will be 0 at the highest point. So you can find the time of ascent, it means to reach to the highest point, by using the first equation of motion. And of course, upward direction, when I am throwing against the gravity, I am taking acceleration as minus 9.8 meter per second square. So if you solve time, you are getting 5 seconds, and the same time will be taken to return by the same height. So you need not find the height, you can simply use the first equation to find the t1, which is time of ascent, and then time of descent will be also same to come down, and total time you can get by adding the two timings, which is coming out to be 10 seconds. This is a very simple question. I think you can do it very comfortably simply by knowing that the velocity at the highest point is always 0. This is a question which you have to work again by your previous knowledge for the distance in nth second. They are saying a body covers 12 meter in second and 20 meter in fourth second. You have to find the distance it will cover in 4 seconds after fifth second. So the question, you have to read it carefully. What is being asked, what is being given. So as second is given 12 meter, as fourth is given 20 meter, and you know the formula for S nth, which is equals to u plus a by 2 into 2n minus 1, where n is of course the time. Here for first case time is 2 seconds and for the second case time is 4 seconds. So first case, when you find as second, which is 12 meter given, you have to put the value of n equals to 2. So 2 into 2, 4 minus 1 means 3. So you are getting u plus 3a by 2. Similarly, when you have to find for fourth second, so which is given 20 meter, here you put the value of n equals to 4. 4 2s are 8 minus 1 means 7a by 2. Here it will come in the equation. So these are the two equations you are getting. You need to work it out quickly. If you subtract both the equations, then minus, this will be minus, this will be minus, this will be minus. So u will get cancelled, and minus 8 you will be getting minus 7 minus 3, 4a by 2. It means 2a. So 2a you are getting equals to 8. So you are getting a equals to 4 meter per second square simply by subtracting these two equations. And if you put the value of this a in the first equation, so you have to calculate. A is 4. So 12 by 2, 6. So you are getting 12 minus 6, that is 6 meter per second. That is the value of u. That is simple mathematics. You can work it out. You can calculate a and u. Now you have to find distance covered in 4 seconds. 4 seconds now. In after fifth second. So you have to find the total distance covered in 9 seconds minus distance covered in 5 seconds. So for that you will be using the second equation of motion, which is s equals to ut plus half at square. U and a are known to you. So you will find the total distance travelled in 9 seconds first by putting the value 6 into 9 plus a by 1 by 2a. It means 4 by 2 into 9 square, and then minus total distance travelled in 5 seconds. So that will be simply putting the value t equals to 5. So 6 into 5 plus 4 by 2, 5 whole square. So on solving you are getting the answer 136 meter. So this language you have to understand, that distance covered in 4 seconds after fifth second. So it means total time is 4 plus 5, 9 seconds. The body is traveling till 9 seconds and you have to find after fifth second. So distance traveled till 5 seconds you have to find, and you have to subtract the. So you have to understand the language to answer this type of question. Very important for nth second. You may be asked with the questions. So I am trying to take every type of question with you so that you can work out NCERT question. Two definitions I want to discuss with you which you can come across. First is stopping distance. Stopping distance. It means distance to stop. So it means what happens when you are traveling in any vehicle, you are moving a car, and then you see a person or a child is coming in front of you. Then you apply the brakes. But still it will not stop at the same minute you apply the brakes. It will travel some distance before stopping. After the application of brake, that distance we are calling it as the stopping distance. So of course we can find the value by using third equation. Final velocity is 0. Initial velocity will always be given to you in the question, and so you can find s equals to u square upon 2a, because next sign will cancel. So you will be getting stopping distance formula. You can use directly also, or you can use the third equation of motion, which we have already discussed with you. So, but you should be able to understand what it is meant by stopping distance. Of course, it depends upon with what velocity you are moving. If you are moving with less velocity, then stopping distance will be less. If you are moving with high velocity, and then of course the stopping distance will be more. And of course it depends upon the braking capacity also, that how good are your brakes of the vehicle. They immediately stops or they are moving some distance. Second definition with you is reaction time. Reaction time is time to you take to react. It means when you are moving in the vehicle, you saw the person in front of you, but you are not at the same second, you will not be able to apply the brakes. You will take some time, maybe 1 second, maybe 2 seconds, depending upon that person. Every person has its own reaction time, because it is your own capability to your own observation, then how you react immediately or how much time you take. So if you ask your friend to leave a scale from a height and then you catch, from how much when you catch, then how much height it has traveled, that can be seen from the scale. Supposingly you catch at 6 centimeter, then you can find your reaction time, because you are making the scale to fall under gravity. So acceleration equals to g. H is known to you, 6 centimeter. Then you can find your reaction time. You takes 1 second or 2 seconds to react. That can be calculated by using this formula, which has been taken from the second equation, that is equals to h equals to ut plus half gt square. And of course, because the scale is being released from rest, so u is equals to 0. So it will be equals to h divided by g square root of this. So this is the formula for the reaction time, which can be taken from the second equation of motion, body falling under gravity. So these are two formulas which are otherwise known to you, but the only language you have to see that we are using two different terms with you. One is stopping distance, another is reaction time. So basis of this, you can work out with this question. A car is moving with a speed 54 km per hour, can be stopped by brakes at least after 5 meter. It means stopping distance is given 5 meter. What will be the minimum stopping distance if the same car is moving with the speed 90 km per hour? Of course, they are giving you in kilometer per hour, so you will be converting it into meter per second simply by multiplying with 5 upon 18, because 1 kilometer per hour, that is equals to 5 by 18 meter per second, or otherwise you can do 54 multiplied 1000 divided by 60 into 60. You convert into meter per second. So u is given 15 meter per second in the first case. Of course, final velocity is 0, distance travelled is 5 meter. So by using equation, you can find the acceleration, means here it is negative sign retardation, because it is negative acceleration, I should say, because the body is coming to rest. So this is the acceleration of that vehicle. It means retardation of that vehicle. I can say negative acceleration. So with the same vehicle, if you are moving with 90 km per hour, of course you can convert it into meter per second by multiplying simply by 5 by 18. You can use this directly, no problem. You are getting 25 meter per second. And retardation is same, that is minus 22.5 meter per second square. Final velocity is 0. So you can calculate the distance, which is the stopping distance of that vehicle or the car here. So that I am getting simply by putting the values, I am getting it 13.8 meter. So very simple question, but you should be knowing what do we mean by stopping distance, and you have to apply the third equation of motion. And the capacity of the car, of course, we will be supposing it to be the same all the time whenever we apply the brakes. So it will simply depend upon the initial velocity given to you in the question. this is a question with you. A car is starting from rest, accelerates at the rate f. It means acceleration is f meter per second square through a distance s. This I have tried to show with the help of the velocity time graph also, that it is starting from zero velocity and it is having the positive acceleration, and the value of acceleration is given to you f. Then it continues at constant speed for some time t, means constant speed means acceleration is 0. Then it deaccelerates at the rate f by 2. It means negative acceleration is there, that is f by 2. If the total distance is 5s, then find s in terms of f. This is the question with you. Of course, this type of question, they can frame many questions from this. They may ask you to draw the acceleration time graph using this velocity time graph. They may ask you to draw the position time graph using the same graph. They may ask you to find the acceleration. If the values are given, then of course area under velocity time graph you can find the acceleration. So from this one question you can write a number of questions with you. Now of course you can find velocity here by using the third equation of motion, that is v1 square. If I am saying the final velocity here is v1, then v1 square minus u square, it is equals to 2as. So v1 is coming out to be square root of 2fs, because the value of a is given f. This is velocity, highest velocity of this. Now with this velocity it is having the constant or the uniform motion. So velocity for the uniform motion is equals to v1, which is equals to root 2fs. So distance traveled s2 will be given by velocity into time. So root 2fs into time t, they have said t time. See s1, which is the area under this first graph, that is given s1 equals to s. For second part, s2 I am supposing. For third part, it is s3. So total distance is s1 plus s2 plus s3, which is given 5s in the question. So s3 also you can calculate by using third equation, but here the initial velocity is v1, that is equals to root 2fs. Final velocity is equals to 0. Then acceleration is given minus f by 2. Then if you use, you are getting s3 is coming out to be twice of s. You can work it out yourself, and this is given to you in the question. It is equals to 5s. Then s1 is s and s3 is 2s. So it means s2 will be equals to s plus 2s, 3s. So s2 will be equals to 5s minus 3s. So s2 will be equals to 5s minus 3s, which is equals to 2s. And you will be getting s equals to 1 by 2 ft square on working out. Because here s2 is this given value. So it means you will put the value of this for s2. And here I am getting s2 equals to 2s. Next question with you is, they are saying a missile is accelerating at a rate of 4t. This is acceleration, 4t. From a position at rest in a silo, means just like a mine, 35 meters below the ground level. How high above the ground will it be after 6 seconds? So acceleration is given from a position at rest. U means the initial velocity is 0 given, and initial distance is 35 meters, s naught. So you can find the velocity by integrating a dt. A is given 4t dt. This formula for integral you should be knowing. 4 is a constant, will be taken out. For t it will be t square by 2, n plus 1 divided by n plus 1. So t1 plus 1 will be 2. So t square divided by 2. So 2 you will cancel by 4, you are left with 2t square. This is the velocity in terms of time. And when I have to find the distance or the position, that is given by integral of v dt. These formulas we have already done. So you put the value of v, which is equals to 2t square. So of course 2 is constant and integral of t square is t cube by 3. Power plus 1 t square mein 2 plus 1 3. So t cube by 3. So you are getting 2 by 3 t cube. But this distance at time t, it is given by s minus s naught, and s naught is given to you 35 meter. So you can use this value for s naught here. And after 6 seconds, if you have to find, then simply put the value of t equals to 6. So if you put t equals to 6 and you solve it, you are getting the answer 109 meter. That means this is the distance which it will go above the ground after 6 seconds. So simply you should be having the knowledge of these formulas on the basis of integration. How can you find velocity and the distance? And then this distance at a given time, it is equals to s minus s naught. These formulas I have written on one side so that you are able to do the things. And of course you should know the integration. Integral of xn dx, it is equals to xn plus 1 divided by n plus 1. Only one formula for integration should be known to you, and constant will remain as it is. That should be known. This is the last question with you, beta. This is again taken from your NCERT. They are saying Galileo's law of odd numbers. That is, you have to prove that the distance traversed during equal intervals of time by a body falling from rest. Body is falling from rest. It means initial velocity is 0. And then it is standing to one another in the same ratio as odd numbers. This is, you can try it yourself. 1:3:5:7. You have to prove it. So you have to find the distance traveled in 1 second, 2 seconds, 3 seconds, and then you take the values for the y equals to half gt square because u is equals to 0. And if you have to find the difference here, ratio, distance between the intervals, 4 y naught minus y naught is 3. 9 y naught minus 4 y naught equals to 5. So that is distance traveled in successive intervals. It means first second, second, third second, fourth second, like nth second we do. So this is on the basis of that only you can prove that the ratio of the distances traveled in each sector 1:3:5:7, so on. So this is again on the basis of your nth second knowledge we have already discussed with you. So you can work it out yourself. Keep things up to this. Thank you everyone.